Good afternoon, friends and students. This is Dr. Baljeet Kaur, lecturer of chemistry at Government Polytechnic College for Girls, Patiala. I am presenting my lecture on polymers and plastics. First of all, we will be discussing, or I am telling you the contents of the topic. I will be dealing with the definition of plastics and polymers. Then we will be discussing about the types of polymerization, the methods of polymerization, the types of polymers, then what are adhesives and what are rubbers. In types of polymerization, we will be discussing about addition polymerization and copolymerization. Now, let us start with our topic. Now, what is plastic? Plastic word is derived from Greek word plastikos, which stands for something to fit for molding, and anything that can be molded into any shape by application of heat or pressure is known as plastic. Mostly plastics are organic molecules containing hundreds and thousands of atoms. So, what is plastic? Plastic is something which can be molded and given any particular shape by the application of heat and pressure. So, we can define plastics as plastics are substances with long chain molecules which can be molded by heat and pressure, sometimes in presence of catalysts, to any desired shape. And plastics are mostly polymers. Plastics are basically polymers. The word, now we will be discussing what is a polymer. Polymer is derived from two words, Latin words, poly and meros. Here, poly means many and meros means units. So, polymer is formed by repeated linkage of smaller units that are known as monomers. So, in a polymer we have many monomers combining together to form the polymer. Let us take an example. Suppose we have polythene. Now, polythene is a polymer which is formed by the linkage of large number of ethene molecules. This is a molecule of ethene. I have not specified the hydrogen atoms over here, but we have a double bond. Now, large number of ethene molecules are combining together. You see here, they are combining one after the other, one after the another, and thus we have the formation of polyethylene. So, polyethylene is formed of a large number of ethene molecules. Now, let us discuss what is a monomer. The small molecules which combine with each other to form a polymer molecule are called monomers, and each repeating unit is called a mer. So, what are monomers? Monomers are the small molecules which combine with each other to form a polymer molecule. Then we have the term that is degree of polymerization. The number of repeating units in a chain formed in a polymer is known as degree of polymerization. That means, how many monomer units are combining together to form a polymer, that is known as the degree of polymerization. Now, let us discuss the nomenclature of polymers. We have two types of monomers occurring. One are the homopolymers and the other are the copolymers. In homopolymers, we have identical monomer units that are being added. Here we are seeing that M1, M1, all the M1 molecules are linking together. So that means all the monomers are of same type. So such type of polymers are known as homopolymer. If now the second type, if the monomer units are of different type, like here we have M1, M2, M1, M2, M1, M2. So over here we have two types of monomer molecules combining together to form the polymer. So such type of a polymer is known as a copolymer. So this is about homopolymer and copolymer. In homopolymer, the monomer units are similar in nature, whereas in a copolymer, the monomer units are of different types. They can add up. So now let us take the exact definition of polymerization. So what is polymerization? Polymerization is the union of two or more smaller and simpler molecules of similar or different types with or without the elimination of water, resulting in the formation of carbon-carbon linkage. So we can understand it that polymerization, in polymerization what happens? We have the union of two or more smaller and simpler molecules, and these molecules may be similar in nature or they may be different in nature. As we have seen earlier, we can have homopolymer and copolymer. Then when they add up, they can add without the elimination of water molecule or with the elimination of water molecule or any other molecule, resulting in the formation of carbon-carbon linkages. So that is what we mean by polymerization. Now we will be discussing about the types of polymerization. Polymerization is of two types. The first is addition polymerization or chain polymerization, and the second is copolymerization. Now what is addition polymerization? It is a reaction that yields a product which is an exact multiple of the original monomer molecule. That means when we are having the formation of a polymer, it should be an exact multiple of the original monomer unit. That is the case of addition polymerization. Now what is copolymerization? Copolymerization is the joint polymerization of two or more monomer species. As we have discussed earlier, we have the polymerization of two or more monomer species taking place in copolymerization. So in copolymerization, the molecular weight of the polymer will not be an exact multiple of the original monomer, because we are not having a single monomer unit taking part, we are having two or more types of monomer species taking part in the reaction. So that is about the types of polymerization. We have addition polymerization and we have copolymerization. This is an example of chain or addition polymerization. Here we have one styrene molecule and many styrene molecules are combining here. You see over here we have the formation of a bond. This is the bond that is formed. This is the bond that is formed, and so on. And this whole structure that is of polystyrene. So this type of a reaction is known as chain polymerization or addition polymerization. This is copolymerization. In copolymerization, we have two different types of molecules adding up. This is 1,3-butadiene, this is styrene molecule. Over here the bonding is taking place. This is the new bond that is formed. This was your butadiene and this is the styrene portion. So, both are combining together to form butadiene styrene copolymer. So, this process is known as copolymerization. So, we have seen what is chain polymerization and what is copolymerization. Now, let us see the various methods of polymerization. Polymerization is of two types, addition polymerization and condensation polymerization. Let us first take addition polymerization. Addition polymerization is the process in which a polymer is formed by the addition of molecules of monomer to each other due to the opening of the multiple bond without, this is the main thing, without the elimination of any part of the molecule. That means simply addition is taking place in this case. There is no elimination of any type of molecule or like water, anything else. No elimination is there in this case. So, that type of polymerization is known as addition polymerization. Let us take the example. This is the formation of polyethylene. Now, this is an ethylene molecule. This whole is one ethylene, this is another ethylene. These ethylene molecules, they are adding up together. Here they are adding, and this is the polyethylene that is being formed. Number of ethylene molecules, so on, they will be adding. We have represented over here. So, this is an example of addition polymerization. Next, so addition polymerization is what type of polymerization? A polymerization in which we have simply addition of the monomer species without the elimination of any molecule. Next is condensation polymerization. It is the process in which a polymer is formed from monomers by combination accompanied by elimination of small molecules like water. Here we have the elimination of other molecules also taking place. Now, let us discuss or take the example of condensation polymerization. This is a molecule of 1,6-diaminohexane. This is 1,6, these are the amino molecules. This is 4 CH2 groups. The second molecule is adipic acid. It is COH, CH2 whole 4 COH. So, we have two types of molecules that are being added over here, and from here H from the NH2 group and OH from COH group. They are combining together to give us the water molecule, and this is the polymer that is being formed. It is nylon. This is the bond that is being formed, NHCO. Over here the bond is, new bond is formed. This is the bond that is formed. This is formed, and we have this A represents the molecule from the diaminohexane, and this is your adipic acid. We have repeating pattern of these. So, this type of polymerization is known as condensation polymerization, because over here we have removal of water molecules. Sometimes ammonia is also being liberated. So, that is about condensation polymerization. So, we have seen that we have two types of polymerization, addition polymerization, that is without the elimination of any molecule, and the second type of polymerization is known as condensation polymerization, and in condensation polymerization we have the elimination of water molecule or some other molecules. Now, on the basis of this addition polymerization and condensation polymerization, we will be discussing the types of plastics. Plastics can be grouped into two heads, the thermosetting plastics and the thermoplastics. First, we will be discussing about the thermosetting plastics. Now, what are thermosetting plastics? Thermosetting plastics are those plastics which when once formed cannot be remelted. They are obtained from partially polymerized semi-fluid polymer of low molecular mass, which on heating in a mold gives hard, infusible and insoluble polymer. And the hardening is due to extensive cross-linking between the different polymer chains to give a three-dimensional network solid. Here, they are highly cross-linked to form rigid, irregular, three-dimensional structures. And heating them does not soften them, since softening requires breaking of the covalent bonds. Heating causes formation of additional cross links and thus makes the material harder. So, these are thermosetting plastics. So, thermosetting plastics are those plastics which when once formed cannot be recycled. We cannot heat them, melt them and reuse them. Once they have gained any particular shape, we cannot give them another shape. That are known as thermosetting. They set once. So, they are known as thermosetting plastics. This is because what happens, we have elimination of some or the other molecule. So, that is why we have thermosetting plastics. Examples are phenol formaldehyde, urea formaldehyde and melamine. Now, let us take examples. This is phenol formaldehyde. This is a molecule of phenol, this is a molecule of formaldehyde. They are combining together. This is the phenol portion, this is the formaldehyde, so on. Addition is taking place but this is by condensation method. First we have a linear polymer that is formed, later on cross linking is taking place. See, these are the cross links that are formed. So, such type of a plastic is a very hard plastic, it cannot be remolded. Another example we will be taking, that is urea formaldehyde. This is a molecule of urea, NH2CO NH2, HCHO methanol. This is giving CH2 NHCO NHCH and so on. So, this whole is urea formaldehyde. Here I have specified as methanol, it is one and the same thing. So, urea formaldehyde is also a condensation polymerization taking place, and this is a thermosetting plastics. Next is an epoxy resin example. This is the bisphenol molecule OH C6H5 C6H5OH. This is epichlorohydrin CH2CH CH2ClO. Both of them are combining together. Over here the bond formation is taking place. This is your bisphenol. Okay. This is the bond that is being formed. This is the bond that is being formed. So, this is your DGEBA. So, this is also an example of thermosetting plastic. So, we have seen that thermosetting plastics are those plastics which when once formed cannot be remolded and reshaped. They will take the shape once and they won't regain it again. Now, the second type of polymerization or the second type of plastics, they are thermoplastics. These plastics soften on heating and become fluid, but on cooling they become hard. This process of heating, softening and cooling can be repeated many times. That means once we give them any particular shape, they will take that shape. We again heat it, it will melt, again we can give it another shape. So, such type of plastics are known as thermoplastics. And there is no change in the chemical composition and mechanical property of the polymer. So, these plastics are recyclable. The recycled plastic that we get, they are all thermoplastics. These polymers can be easily molded into any desired shape by heating and subsequent cooling at room temperature. They are either long chain or branch chain macromolecules but not cross-linked, and due to weaker intermolecular forces they can be easily softened on heating. The stiffness of these plastics can be increased by adding plasticizers. Because these are quite soft plastics, so if we want to increase their strength, we can add certain substances that are known as plasticizers. The example is polyvinyl chloride. Now we will be taking the examples. This is polythene that we have already discussed. Ethene molecule forming polyethylene. You can see it very properly. These double bonds are breaking. This bond is breaking, this bond is breaking, and over here a bond is being formed. This is one whole unit, this is the another unit, and their bonds broke and this bond is formed. So this is an example of a thermoplastic. Another example we can take. This is polystyrene, already we have discussed. This is one styrene molecule, this double bond will break and another, this bond will be formed, this will be breaking, this will be formed. So many styrene units add up to form polystyrene. Another example is polytetrafluorine or ethylene Teflon that we commonly call it. This is tetra, 4 molecules of fluorine, tetrafluoroethylene. This is undergoing polymerization and this is forming polytetrafluoroethylene. This is the molecule that is being formed. This CF2, CF2, CF2 again and again. So these are molecules of polytetrafluoroethylene forming Teflon. Teflon is mainly used for non-stick cookwares that we have. They have a coating of Teflon inside it. So these are addition polymers. So we have seen that we have two types of plastics, thermosetting plastics and thermoplastics. Thermosetting plastics cannot be remolded and reshaped. Thermoplastics can be heated, melted and remolded to give any shape again. And we have seen the examples also. In thermosetting plastics, we had the urea formaldehyde, the phenol formaldehyde, epoxy resins, and thermoplastics we have polyethylene, we have polystyrene, we have Teflon. So this is about the types of plastics. I hope you all are understanding it. Now let us discuss the properties of plastic. Plastics have low specific gravity, that is less than 2.4. They are light in weight. They are bad conductors of electricity and heat. That is why they are mostly used in switches. The thermosetting plastics are used to make electrical switches, that is bakelite, which is urea formaldehyde. Then they are easily workable and have low fabrication costs. We can mold them, cast them, cut them, drill them, so they can be easily workable. Then they are impermeable to water. They do not absorb water, rather they are water repellent. Then they have low coefficient of thermal expansion. They have good abrasion resistant. We can give them excellent finish, and they are chemically inert, that is they are not attacked by corrosive chemicals like acids, alkalis, etc. Then so these are the properties. They are bad conductors of heat and electricity, easily workable, impermeable to water, they have excellent finish, they have good abrasion resistance, they are chemically inert. this is about the plastics, properties of plastics. Now, let us take the uses of plastics. So, plastics can be used for making electrical goods, because I have already told you all they are bad conductors of electricity. So, they can be used for making switches, plugs, sockets, etc. Then you can use them for making furniture. Due to corrosion resistance, easy molding, low maintenance, they are used for furniture making. We have chairs, tables, etc. made up of plastics. So, they are all because of this reason. We can easily mold the plastics. Then thermal insulation. They are good thermal insulators when formed. Styrene foam, polyurethane foam. Styrene foam is your thermocol that we use for thermal insulation. We use them in tiffins and anything, bottles, water bottles, etc. So, they are also used in refrigeration also as insulators, and air conditioners also they are used as insulators. Then they are used for making synthetic fibers due to high abrasion resistance, ability to take colors. These are widely used as fibers. Example, nylon, polyester, etc. Then plastics can be used for making films. Due to good strength, toughness, corrosion resistance, they are used as films. Then they are used for making household articles due to their easy molding, chemical inertness, corrosion resistance. They are used for making articles like tubs, buckets, mugs, combs, trays, etc. We can use them in automobiles, in aeroplanes and in two-wheelers. Due to the corrosion resistance, easy molding, plastics like PVC, etc. can be used in such cases. Then they are used as substitute for rubber due to good strength, high resistance to abrasion, lightness in weight, chemical resistance. Polymers like neoprene, thiocol, Buna S, they are excellent substitute for rubber. We will be taking rubber later on. They are used in footwear industries. We have PVC soles. They are also made up of plastic. Then in household building industry also we are using, due to their low maintenance costs, water resistance, the ability to take colors, lightness in weight, they are used in house building industry. So, these are the uses of plastics. So, we have seen that plastics are used a lot. Everywhere we have plastics that are being used. Now, let us discuss the molding constituents of a plastic. The first constituent of a plastic is resin. What is resin? Resin is the binder that holds the different constituents together. Thermoplastic polymers are supplied as linear polymer of low molecular mass, and the conversion of fusible mass into cross-linked infusible mass takes place during molding itself in presence of catalysts. So, that is resin. So, the first constituent of plastic is resin. Then second constituent, plasticizers. Now, we have discussed this earlier also. Plasticizers increase the plasticity and flexibility of the plastic. They neutralize a part of the intermolecular forces of attraction between the macromolecules of the resin. So, that is about plasticizers. The common plasticizers that we use are esters. Example is dioctyl phthalate, dibutyl phthalate. Then we have oils, we have chloroalkanes. All these substances can be used as plasticizers. The third constituent is fillers. Now, fillers are added to the plastic to give the final material a better appearance, finish, better hardness, tensile strength, workability, etc. They are cheap and they also reduce the cost of the article. and we can increase the percentage as high as 50%. So, fillers are the substances mostly used by people to reduce the cost of the article. The example of fillers are china clay, talc, marble powder, metal oxides, etc. So, this is about fillers. Now, the next constituent of plastic is lubricant. Lubricants are also